Hello everyone. In this video, we are going to learn about method overloading in C++, which is an important concept of compile-time polymorphism in object-oriented programming. By the end of the session, you will understand what polymorphism means, what method or function overloading is, the rules for creating overloaded functions, and different ways in which functions can be overloaded in C++. So let's begin with the concept of polymorphism. The word polymorphism means many forms in programming. It refers to the ability to use the same name or interface while obtaining different behaviors depending on the situation. Polymorphism is one of the core principles of object-oriented programming. It makes programs more flexible, extensible, and readable. In C++, polymorphism can broadly be classified into two types. First is compile-time polymorphism, and the next is runtime polymorphism. Compile-time polymorphism is resolved by the compiler before the program starts executing, whereas runtime polymorphism is resolved while the program is executing. Compile-time polymorphism is also known as static dispatch or early binding, whereas runtime polymorphism is known as dynamic dispatch, or otherwise it's also called as late binding. So now let's start with what is method overloading. Method overloading, also called function overloading in C++, means defining multiple functions with the same name but different parameter signatures. The compiler distinguishes between the overloaded functions based on their parameters. There are three important ways to differentiate overloaded functions. First is by the number of parameters, second is by the types of parameters, and third is by the order of parameters. However, there is one very important rule to remember. Return type alone cannot differentiate overloaded functions. The compiler examines the function call and selects the appropriate version during compilation. Now let's understand why method overloading is useful. Suppose we want to perform addition of integers, floating numbers, or different number of values. Without overloading, we might create separate functions called add int, add float, add double, etc. So this can make program unnecessarily complicated. With method overloading, we can simply use the same intuitive function called add, okay, without knowing the internal types. And add can be called for any related operations. This improves code readability and provides clean and consistent interface to the programmer. Let us look at the important rules. Overloading is valid when functions differ in the number of parameters, types of parameters, or order of parameter types. It works for both global functions as well as class member functions. On the other hand, functions cannot be overloaded merely by changing their return type. Similarly, changing only parameter names does not create a new function signature. We should be very careful when implicit type conversions are involved because they can sometimes make an overloaded function call ambiguous. Now let's look on to examples. Starting with overloading by number of parameters. The first type is overloading by parameter count. Okay, this is one of the simplest form of function overloading. Here there are two functions. One is add function with two parameters. One is a and other one is b. And next function is add with three parameters a, b, c. So here when we call this add 3, 4, our compiler automatically reaches the first functions, that is add a, b, and it returns the value 7. Whereas add 3, 4, 5 is called, compiler selects the 3 parameter version and produces the output to be 12. The selection happens at the compile time here. Next, coming to the overloading by parameter types. So here consider the example display int. We are going to displays a function. It holds parameter of integer type. Another function display holding a double type. Another function display holding a string parameter. Okay, so when we call this display 42, automatically our compiler understands and takes to the display int_x function and displays the integer. Similarly for the double and string values also. The same function name can be used to process different types of values. This is demonstrated here. However, we must be careful with implicit type conversions because in some situations a compiler may have more than one possible overload may have more than one possible overload to consider. So next, coming to the overloading by order of parameter. This is the third type. In this case, we have an example program here. The function is describe. Here the describe holds two parameters. One is integer value and the second one is double. The next describe function holds similarly two parameters. One is double, second one is integer value. Okay, now describe 5 comma 9.99. So it means the first parameter is the integer and second one is double. So automatically this function goes to the describe int count comma double price. So therefore the compiler selects this particular first function. Okay, and although the technique is the output demonstrates the order of argument types, describes which overloaded function is called. Although the technique is valid, it should be used carefully because excessive reliance on parameter order can sometimes make a program less readable. Next is coming to the constructor overloading. Another important application of overloading in C++ is constructor overloading. The constructor overloading means defining multiple constructors within the same class with different parameter list. So this allows the object to be initialized in different ways. For example, consider rectangle class. We can define default constructor rectangle, which creates a rectangle with width and height of 1. So we define rectangle in w comma int h to create a rectangle with separate width and height parameters, as well as we can create a rectangle with parameter called side to create a square by assigning the same value here. So when we create rectangle R1, the default constructor is selected. When we create a rectangle R2 4,6, the constructor with two integer parameters is selected. Similarly for rest also. This demonstrates that the constructors follows the same basic overloading rules as regular member functions. So to summarize what we have learned in this video, polymorphism means one interface or name can represent multiple forms of behavior. C++ supports both compile time and runtime polymorphism. Method or function overloading is a form of compile time polymorphism. The function can be overloaded based on the number of parameters, types of parameters, and the order of parameter types. However, return value alone is not sufficient for overloading. Thank you.